Hello YouTube viewers, welcome to my channel Science to Technology. This is part 2 of my Fume Extractor. So today we're gonna focus on the CAD part of it and basically how I managed to slice it and all that, and some tips and tricks which I can guarantee, unless you are a very pro level 3D enthusiast, you most likely would find helpful. So what was my intent? My intent was to basically make a different variant of this, which is far more professional. As you can see, these have screws on the outside, not desirable, and a lot of air gap, very bad. So let's look at that CAD file to understand what I was making, what I was thinking when I was making it. So this is Mark 3. Let's start with Mark 1. So this was what I made. So I had basically two types of fans are used, a slimmer one and a fat one. So backside is the fat one, which is 38 millimeter thick. I made a C clamp, and then I made a different C clamp, and this was the place where I would have put my air filter, and this blank space between these two were used for what you call activated charcoal filter, which again I made. That was the charcoal filters block. I printed two of them to get the job done. Now all of this did work, but problem is too much gap was there. For example, here you can see from this to this there is a almost 6 millimeter gap, and from here to here another 6 millimeter gap, from here to here another 6 millimeter gap. That's way too much gap space. Three gap spaces of that thickness, yeah, wasteful. So and again I thought this printing style where I'm just printing the bars would be easier. It did work, it's a physical thing, but it was not a very efficient. It did not work out the way I thought, and it was very weird. So I realized I needed to make Mark 3 of it. So now if you wanted to see how I actually model all of this, I unfortunately not unfortunately, like I did screen capture all of it, like real time, no sped up or something like that, and I'm uploading all of it, as in like 2 hours of it, in my Hindi channel. If you want to watch it as a time lapse, or just watch it mute it, have some other music playing, you can see all the steps that I took to model this. So this is the final product that I'm expecting to print out. Now, so far the panels are not printed yet. They do take time, and I have a very cheap printer. It's a Ender 3, so I do expect it to be very slow process. So now let's dive deep into it. Now, the first thing you must understand, please name everything properly. Whenever you are dealing with CAD file, do yourself a favor for your future variant, name everything. If Mark 3, measure it Mark 3. For example, this is Mark 2 filter. This is Mark 3 footprint. Now, another aspect is try to be as symmetrical as possible. So this will make your life easier. For example, as you can see, I started everything from this central cross. Everything else becomes very easy when you do that. So doing this, let's say I go edit sketch, and you can see everything is measured. Now be mindful, if you want to move something or attach something, use dimensions. Dimensions gives you freedom. So what is my intent here? My intent is to get this block printed. After that, another would be same block would be a bit taller. So the concept is, this is the fan block. So I wanted a bit of space here. Why I wanted space here? Here it will be sealing. If it's loose, I can use a gasket material, some foam block to seal it, but I needed a place where I can have wiring. Now wiring, I can also maybe choose to use a 25 millimeter fan, normal PC fans, rather than thicker industrial ones. Again, this gap still would be there. It will allow me to wire it, and this place, you can see this length would be enough to seal against anything that I desire. So I will get perfect seal from one side. And how it's going to be printed, that's the most critical thing. For example, I open a slicing software, you can see here, and I import file into this. So this is what we are talking about. So here's the, this is how it's going to be printed. Now be mindful, do not print like this. You must make sure the alignment is optimum. Z axis, like moving in this axis on normal Cartesian bed, is very slow, so you do not want movement maximized in that direction. Now you slice it. Now you always pay attention to how the print lines are doing. As you can see, I'm getting quite a lot of thickness here. Again, this is by design. And if you like how I'm exactly getting this many counts, here's a very simple trick. It will help you a lot whenever you are modeling something. Let's say you are modeling, if let's say you have to make a shape, right? Let's say you made the shape and you're like, I have to give some border to it. How do you do that? One very simple solution. Whenever, let's say, you want to do this, you take your nozzle width, that is, let's say 0.4 multiplied by, let's say in my case, I want 8 lines there. I will be like this. This is how you make sure you always get exactly the right amount. You do not get too much spacing or gap. Printer can compensate by squishing or letting it expand over expansion, but you do not want to rely on it. That should be just like helping it out. So that will be the easiest way you can have thickness which can be safely printed without any issue. Again, you can multiply this by a larger number. Let's say you need a big number, so you're like, okay, by 18 times. Okay, now you can have another let's say line here, which is, I know, a dimension, okay, but like, okay, in this scenario it's not letting me do what you call final sketch. That would have helped, but let's say I did this. So another trick would be, if you needed to have a curve, which you should always have, because again, printer is not CNC machine, it does not do 90-degree quite well. If you want a bit of chamfer here, let's say you have chamfered it, let's say 2 mm, that's your chamfer. How do you make sure that another line that is following it will get the perfect chamfer? This is the most important part. Select it and move it upwards. This auto adjusts the curve. This curve and this curve is auto adjusted, meaning if you have a tracks, it will follow it perfectly without any issue. This is the easiest way to guarantee. So always use, if you make sure you are using internal what you call radius, and external one would be computed, and here you can be like, okay, 0 0.4 0.04 multiplied by 8. That's it. I'm too zoomed out. Oh, 0.04, that's fine. Yeah. Oh, and this is coming inside, generally not recommended. So you can have -1. Again, different software will have different things, but this is the intent. You always want the layers to follow each other. If you do not, let's say you did it manually, right? Let's say you did it manually. You're like, okay, I'm gonna give a chamfer internal edge. I'm gonna give a chamfer, right? Oh yeah, I can't mess it up. That's how I designed it. That's a good problem to have. I designed it quite well. Okay, so let's say you give chamfer here. Let's say you gave the chamfer 10 mm. Now you're like, okay, I'm gonna give a chamfer similar here. Now let's look at 10. You think this is perfectly fine, and you're like, no, it looks off. Like this is much fatter here compared to here. That's the problem. You cannot do it manually. I mean, like there is a mathematical calculation that will calculate a point from here to here, point from here. It's like too much work. Just use normal, layout. That's how you can make sure all the lines are perfectly spaced out. And use center of grid. And when you have the parts that need to be moved, move it after you modeled it. That's the easiest way. Do not be tempted. It's like, oh, what if I model some, let's say you have some mesh, right? Let's say this is the filter box, and what if I model directly from here? Do not try to do that. Like Fusion 360 does allow you to do that, but try to avoid it. Trust me, otherwise your file will have way too much mess. So let's look at the, and as you can see, base. Oh, that's why. And chamfers have to be thought through, as in like, as you can see, I have chamfer here. Why? Printer is going like this. You can see it in this. If you do not give chamfer, printer will try to compensate for it to the best of its availability, which is not gonna succeed quite well. So it might give you a joint where it tries to retract and extrude again. It will be a mess situation. So trust me, it's always better to have file directly itself containing the chamfer. You do not want slicing software to force it, which it cannot physically print. And another side is, I always give a bit of, you can say, chamfer from top to bottom. This also alleviates elephant foot. That's why I do it. That's why there's a little bit of chamfer here. So as you can see, this is the printout file of that. It does work. Holes were there because, again, fastening everything. In this designs, I have nut bolts sticking outward, which is not acceptable. So in the final variant, I have screw that is hidden, so you will not get caught on anything. So you screw from here, and if I do a X-ray mode, yeah, you can see I can put a screw from here to here, and it will hold the file. Now, okay, so what about the center part? There is no screw hole there. The screw hole is not there because I have this latch. Basically, this, and I have this on the top. I have not printed the large one. I'm gonna print it. It's gonna take freaking overnight print. I latches from the outside and then folds inside, and I screw from this side. Benefit: no holes. Screws are visible from outside. Everything is smooth. And again, smoothing is very requirement because I want it to be airtight. So if gaps inside is not perfectly, let's say, because there is a bit of curve, it folded a bit. I do not have a chambered 3D printer. Even on PLA it does fold, especially if you are printing long parts. I can just tape it. Everything would be airtight. That is why I want to make sure I do not have any protrusions on the outside. And you can see the chamfers. Let's change the view. Okay, now let's say take this mesh. How the heck this mesh supposed to be printed? Let's isolate it. This is side panel A, isolate. Now pay attention, I have this curvature. Why? Because this will go on the print bed. So this becomes an overhang. If I did not had it, it will not print it properly. It will require support material, which will be wasteful and time consuming. So now if I slice it, let's take this mesh and let's go to prepare. Let's delete this. Let's import something and voila. Now this is not, I'm gonna print it, of course. This messed up. Now, ta-da, yep. So now I slice it. As you can see, its computer is telling that it is a bit of overhang, but now I preview it. Now let's see. As you can see, it's not making a huge jump in basically every. It's a little bit of overhang, and even if it does not do a perfect job here, it's still one layer above. As you can see, it's taking a little by little by little, little by little, little by little, and then it goes up. It's not an issue. It won't be perfect, but it will do the job right. So I do not have to worry about it. And that is why I have curve on basically this angles to make sure. You do not have to worry about 90 degrees like this. If this is the print bed, 90 degrees like this, no problem. But 90 degrees where print head is going, it cannot be done. So 90 degree, this one will not print. But I had to do it because otherwise print head will be stuck in the air. Trying to take a 90 curve in the air, that's not gonna work. And 90 degree, if you have like this, printer tries to do it as sharply as possible. That's why I did not give 90s here. Print time would be brutal, 4 hours, damn. And these are the screw holes. And again, better design would have been I had screw hole through and through. Now that would have worked, but problem would have been I had to buy M3 or M4 screws, which would be expensive this long. It's like, you know, this long, it's like almost a foot long. So that would be expensive. And if you print something that big in through hole, yeah, even if you have infill set to 0, it will consume a lot of infill because it had to build support structure inside. For that reason, that option was scrapped, and I have very, very shallow holes. As you can see here, like the hole is not very deep. All it just needs to do is like from two side. I'm gonna stop it, and a little bit of gap has to be maintained. From here you can see the curve on the body, and this also helps me printing this one. For example, I'll show you. Let's do this one. Let's delete it, prepare it, prepare, open. I'm printing with this. Okay. Ta-da, slice. Now when I'm sliding, this becomes an overhang. But again, it's switching so swiftly. And again, I have printed it. It did work. Not too much. It's not perfect. I mean, like you can look at it and be like, okay, this side is like this, and this is underhang. But it did work. In both of them, it did work. It did do the job. That's why chamfers have to be there. Learn to use the chamfers. This holes is not an issue. And no, as you can see, I have curve from all sides. That allows me to not have elephant foot. There is no elephant foot into this. And curve also allows, and 90 degree going up from the print bed like this is not an issue. You can see the preview. This is not an issue. It's like layer set without an issue. So this is how this side is printed. Now, the biggest issue is while all the frames is done and I will print today the side walls, the only thing that is I'm still figuring out is how the heck I'm gonna make filter clamps. Basically, in this one, I manually made it. It worked, but this time I'm trying to figure something out. This is the filter block unit, and again, because this is too tall, I cannot print it in one go, no matter what I do. So there has to be a slice here. What happened to the slice? Sweet. Yeah. So you can see this is how I'm gonna print it, but here's the deal. Yeah, this part, the C shape, that's folding everything. That has to be printed vertically. Yeah. This internal block thing, not an issue. Again, it will make more sense once I actually print it and have a net around it. My aim is to use net like this to contain all the activated charcoal. Can you print it? Yeah, but that would be way too wasteful and it won't be as good as this. So that's why I'm not doing that. So there is that. This took time. In terms of bottom, I have no idea, so I'm gonna use a aluminum sheet. I have a very thin aluminum sheet, almost like a foil. It's a bit more of like 0.5 millimeter thick, or even slimmer than that. I'm gonna fold it and using these screw holes, make a bottom cup, so to say, a very small cup, because again, I do have to make sure the fan air is not blocked. As you can see, yeah, I get only this much space where I can have a cup. A little bit of thickness would be there, but it would be what it is. And again, whenever you are working like this, you can utilize the insert command from, like, make master card, and then you can just have a, generally almost all physical products are there in Mastercard, so you can utilize that. And voila, like this was my slimmer fan, and again I made sure that it's compatible with both of them. So if I unhide the object, as you can see, wire, again wire also you have to think about. If you do not, you will learn the hard way. So let's go to the top view, and I'm gonna hide now. Okay, as you can see, the fan will go deep. Still, it will have space. Let's, why the heck, T. B. Okay, now let's move it. Moving it. Yep. So now you can see the fan. I still have this empty space for wiring. Still has a positive seal on this edge. Would not have an issue. Curve does not interfere too much. That's also an issue. Sorted. So now this puppy is ready for, basically, let me make this. So, let me move this one also. On this side, ta-da! So now you can see all the fans. I still have place for wiring. I still have a place for gasket. If I want to make sure it's very tight, it does not block any airflow from inside. It will be completely tight. There will be that charcoal filter, and then I will have filter. This is the Bosch filter that I'm using. So these are the things that I've learned and used, and so far printing is going well. Wish me luck for the big one. So, and now the only thing I'm trying to figure out is, like, I have a way of attaching screw from the underside without anything coming on there, because most fans have empty space here. You do not have to worry too much about, like, I put a nut from here and screw down from this side. Does it work? Yes. I built a spacer holder because I have a lot of M3. These holes are M4, so I needed a spacer and a nut holder. So I got it. I can glue it and it will work well. But it's not very perfect. It's very tedious. So I'm thinking about something else. If you have any idea how to have a blind hole on something like that, do help me with that. That's unknown. As you can see, that wall printing that I was talking about, as you can see, this curve will allow me to print, and because of the screw holes, I can screw it. No tapes required. So this was my presentation on basically how I dealt with the CAD modeling part of it. And if you guys want to watch like actual CAD modeling, I also have that, but unfortunately Hindi audio. So that's there. Hopefully you have liked the part 2 of it, where I'm dealing with CAD, and then next part would be physically building the things. So see you in part 3. Bye.